Yeah, welcome everyone to our session today. For those of you who don't know us, we're here from IMAGINiT Technologies. So just like to do this quick intro slide. We're a partner with Autodesk. We have a staff of over 100 people and 25 plus years experience. We are a platinum partner, which is the highest level of partnership you can have with Autodesk. So kind of just wanted to put this up there, but we can get right to our intro. So Jeff, I'll let you introduce yourself.
Welcome everyone. My name is Jeff Bowers, as Vince said. I am the reality capture technical manager for all of IMAGINiT Technologies. I personally have 25 years of experience in the industry. My background is I am a process engineer. I've certified expert or certified professional in Revit implementation of the software. I specialize, my team specializes in all things reality capture. That includes 3D laser scanning with Leica, the recap, the Leica Geosystem software. And again, we take that data, get it put into all things Autodesk, and make you successful.
Cool, thanks, Jeff. And I am Vince Danielli, Building Solutions Division Team Manager. 15 years experience for me, mostly in architecture. I am also an Autodesk certified instructor, professionally certified in Revit, AutoCAD, 3ds Max, and specialize in anything really related to BIM, BIM 360, ArcViz, Revit, 3ds Max, Twinmotion, and a whole bunch of other consulting services. Before we kick into the formal presentation here, just to give everyone on the call a quick rundown, Jeff and I will be co-presenting this one. So the first part here is just a quick slideshow or presentation deck. We didn't want to spend too much time just going through PowerPoint slides. So I'll kick it over to Jeff in a second here, but then we're going to get into some different software and show you how reality capture can tie into not only visualization workflows, but how we can actually use laser scans to create Revit data, Revit models, plus maybe using it in a different way to create some mesh surfaces and have a discussion about why we would use one versus the other and kind of where we can use them in our day-to-day typical workflows. So with that, I will pass it over to Jeff here to kick it off about the reality capture.
Thank you. All right, so what we want to do is we're just going to spend a few minutes kind of going over, making sure that everyone has a very good idea of what reality capture is. How do we use it? Where do we use it? What is it? So, you know, thinking about reality capture, basically it's taking into context to the existing surroundings, okay? How there are many different types of reality capture. And as you can see, 3D laser scanning is one of them. Aerial LiDAR, mobile LiDAR. Then we have, for mobile LiDAR, we have photogrammetry. We also have ground penetrating radar. And the last one is sonar. But does anybody see one that's missing? I mean, we've been doing reality captures for forever. Yeah, that's right. Even a tape measure, pencil, and paper is reality capture. All right, let's be honest. Is it accurate? Nah, it's accurate depending on how we feel that day. But now that we have introduced all this new technology, you know, you're going to hear a buzzword, point cloud. What is a point cloud? What is it? So I'm not going to read word for word, but basically this is the scanners or whatever device we're utilizing are shooting out, you know, camera pictures or lasers, getting returns. Every time we get a return, that's called a point. All right. That point has an XYZ coordinate. All right. We can utilize these point clouds for many different things. All right. We can utilize point clouds to recreate Revit models. We can use these point clouds to recreate visualizations. How many of us play video games? I know I do. How many of you know that point clouds are used in video games more often than not? For instance, Microsoft has a fantastic game called Forza. A lot of the Forza tracks, race tracks that they have in the video game are laser scanned. They're laser scanned by traditional 3D scanners and also by mobile LiDAR. Some of them are done by aerial LiDAR. But being able to capture that point cloud data very, very accurately and be able to take it into things like 3ds Max or other softwares to create meshes, to create models, to even render the point cloud, it's a huge time savings in the end. Next slide. So looking at this, point clouds can help us create workflows, okay? So we can have their point cloud, kind of like I said a while ago, we can have that point cloud in the native format where we take that, we take it into a software like 3ds Max, do some renderings with it, utilize it to create our background, right? Another way is I can take that point cloud data and create geometry from it. This is huge in the AEC world because what we're able to do is instead of us taking that tape measure, taking multiple people out to the field, we can now take a scanner and start recreating structures from that point cloud data. And that flows right into that BIM deliverable. I can utilize that point cloud to assist me in creating that BIM deliverable. Is it hard? No. But then, so that kind of talks about the point cloud data, okay? You want to do this, Vince, or you want me to take photogrammetry as well?
Sure, I can talk about photogrammetry. So just building off of what Jeff was talking about with the laser scans, a different format to gather this data is using photogrammetry. And the process of photogrammetry is we take a series of still images. And the reason I say still images is that we could take several hundred of different frames or pictures around the surface or something, or we could even hook up, like Jeff mentioned, for aerial LiDAR. You could put a GoPro or something on a drone and basically create a video capture of a plot or site. And what that's doing is it's gathering a video, which in essence, a video is just thousands of pictures, right? Thousands of frames that we can then stitch together to create a 3D model. So using different techniques, and there's some different things that go into photogrammetry. Lighting can affect it. So some outside forces that don't necessarily affect the accuracy of, say, a point cloud can come into play with photogrammetry. But as Jeff mentioned, we're starting to see more and more of this, and not only for video game application or for maybe scanning a surface where we might not necessarily have access to a laser scanner, an expensive laser scanner, but you can even use your phone to start to capture these different things. And one thing I'm going to highlight in this presentation is how we can take what we get from photogrammetry and then leverage it into different visualization workflows or different programs like Twinmotion or like 3ds Max. So
yeah, let me add one thing about photogrammetry, Vince, if you don't mind.
Sure.
Be mindful. Photogrammetry is a fantastic, fantastic tool, but you do need to be mindful that it's not quite as accurate as traditional laser scanning. All right. Depending on it, with photogrammetry, it truly depends on quality of equipment that you have and the processing that you do. Fantastic tool. Just be mindful, it's not quite as accurate as your point cloud data.
Right. So yeah, you have to definitely balance or identify when laser scanning should be appropriate versus when using photogrammetry techniques should be appropriate. But it's just nice to know that we have these different options. And in this presentation, you'll even see, based on some of the stuff that Jeff will show with point clouds, the differences in the accuracy and the points that we get. In this slide, I just kind of wanted to pull an image to show what we get from photogrammetry. So there are really two main components to what we receive in a digital format from photogrammetry. One is the surface. So unlike a point cloud where it's millions and millions of points that are floating in space, XYZ coordinates, with photogrammetry, we get a surface. So basically what it's doing is it's connecting the points and creating a mesh surface. And a mesh surface is a collection of triangles to create the shape, to create the object. So the image I have to the right here, on the right side of that image, you can see that with photogrammetry, you're using photogrammetry techniques. This is just a wireframe surface, and it's made up of millions and millions of little triangles tessellated across that to create the surface. Once we tie in a material to that surface, things start to look pretty realistic. So you can see how this could be really useful for visualization techniques. One thing to keep in mind is both with laser scanning and photogrammetry, the higher density of the points or the mesh, obviously there are going to be hardware limitations there. So it's always something that you have to be mindful about when gathering this data as well. And we'll look at some of the different levels of detail that we can use in this process. So in our demonstration here, so this is going to kind of conclude most of our slides, but we'll show these different solutions in our demonstration. For reality capture, there's all different types of programs where we can register the point cloud, we can set it up and align it. We're not going to go into too much detail in this presentation on that. We're kind of taking this from we've already processed the point cloud, or we've already gathered the photos from photogrammetry or created the mesh, but now what can we do with it? And here are some of the programs that can be utilized. Jeff's going to show us some stuff with CloudWorks inside of Revit. We've got some other programs here that we're not necessarily going to show, but you've probably heard of Pix4D for photogrammetry. A really nice free one that's out there is 3D Zephyr. So if you're interested in just kind of a hobbyist and you want to play around with these tools, that's a really good one to kind of test it out and see what you can do with photogrammetry. In a visualization workflow, once we already have those sort of processed, the surfaces or the point cloud, I'm going to show you inside of 3ds Max what that looks like and what we can do with those surfaces, and bring it into Twinmotion. But there are some other things that I'll talk about in my part of the presentation here. So with that, I will go ahead and turn it over to Jeff to show the RCS stuff. So Gladys, do I share this, or do I have to give the presenter back to Jeff here? Or can he just kind of take over?
One sec. You want him to be able to share it?
I found it. I think I got it here. There we go.
Fantastic. All right, so now that everybody can see my screen, a couple things I want to do is I'm just going to give you a brief intro into looking at point clouds, different ways of looking at them, things we can do with a point cloud. This happens to be a pretty small point cloud. It is of our Richmond office here in Richmond, Virginia. And we went in and we did about 15, 16 scans. Took about 35, 45 minutes, somewhere right in there. But what does that get us? All right, so in that extremely small amount of time, I am actually able to come in here and take a look at this building basically virtually, okay? There we go. So I've done several things here, all right? I am having screen issues. Can you guys still see my screen, Vince?
Yeah.
Okay. The GoToMeeting does not like my screen. Every time I navigate, it closes out.
Really? Okay. I mean, it looks fine to me. I can see the Jetstream viewer in your gizmo in the middle there.
All right, my screen just goes black. All right, so with these laser scanners, we're able to do so much. All right, if I want to have a scanner set up in this room, I can scan my room. If I want to, I can take it. Even I can set it above ceiling tiles. There's so many times where, there's so much information that we need above ceiling. I have the capabilities of taking that scanner, setting it above that ceiling grid. I can set it right on the ceiling grid. It's only a couple pounds. Look at the information that I'm able to gather. This is not something that, you're going to get on a ladder and you're going to document each piece of conduit. Well, we wouldn't document conduit because, as you guys can see, it's kind of just laid there anywhere. So, but again, this would give us the opportunity to not only see the scans, but also gives me a good, crisp, clean shot of the building. Now, with that said, understanding the point cloud is pretty simple. But how do I start working with that in a Revit world? So what you're going to notice here is I've come in here and I've simply brought this point cloud in to Revit using what we call CloudWorks for Revit. It is a third-party tool. We're not here to sell you the tool. I just want to show you what's available and what we can do with point cloud data. So if I wanted to come in here and utilize this point cloud to recreate this, I have tools where I can come in and say, you know what, let's create just a very quick slice of that room. So when I do that, it's actually going to take a second and it's going to actually cut a Z slice of my building. All right, that's going to allow me to start reworking or working with this point cloud data. Now, at this point, if I wanted to just really, really, really quickly start putting in walls and things, I've got tools where I can come in here, start picking various lines. All I got to do is follow this around and start basically, for lack of better terms, I'm just tracing this with a simple piece of polyline that this tool is putting in for us. So I'm not spending a tremendous amount of time trying to be accurate, because what this tool is going to do, as soon as I hit escape, it's going to say, hey, what do you want to do? I want to put in walls. So let's go, just a standard partition wall. I want it to go toward the left. I hit OK. Right there, I've already started to create that architectural base plan. Now, fast forward in the process, I have our model already built. And if you look at this, I can actually come in here, bring in that point cloud, and it will lay right on top where that model, where that Revit model and that point cloud are. So, looking at it from this point of view, real numbers, it took me, we'll call it 40 minutes to scan, 20 minutes to process, and 30 minutes to build it in Revit. So I've got way less than 2 hours wrapped up in this, and I already have an as-built model. Now, that includes walls, windows, doors, floors, ceilings. It's a simple building. But again, it just goes to show you that just in a matter of a few minutes, I can have a very, very accurate model. Very easy to do. Now, once we have this Revit model, then is when our visualization starts. So to recap what we talked about, getting the point cloud data from the scanner, that's step one. Step two, we process that data and get it into the consumable being Revit, AutoCAD, MicroStation, SolidWorks, Inventor, whatever software we're going to use, we're able to utilize that point cloud data in almost every software. So, with that said, I will turn it over to Vince.
Cool. Thanks, Jeff. I think you just have to switch me to presenter. There we go. Awesome. Thank you, sir. All right. So getting into the visualization then, and I do want to kind of add to what Jeff was showing. For a visualization, we can think about visualization as a nice polished presentation piece, and that's kind of what I'm going to get at here. But always keep in mind, even in that Jetstream viewer, and I know Jeff was having some difficulty with showing you that in this go-to meeting, but even with that Jetstream viewer, you can do basically a walkthrough of the existing building based on what you're getting from that laser scan. So even without having to model these things in 3D or create meshes from them, you can get to a very nice representation of the space without having to do really anything else other than process your scan. So I wanted to point that out because we always have to keep in mind, what is our use case? What are we trying to get at here? Are we trying to just look at the space as it exists without any design data on top of it? Or are we trying to use that existing data like Jeff did to create a very accurate model, and then we can start to do some redesign to the space, or maybe do some phasing and renovation to it? What we've done here for this presentation is that model that Jeff created from CloudWorks and Revit. We saved that out as an FBX file out of Revit. Now, with Twinmotion, there is a plugin. It's called a direct link, where we can click a button and it pushes it right to Twinmotion. It's a pretty cool option because if we were to make any changes to our Revit model, we can click the See in Twinmotion button and it automatically updates our model here in Twinmotion. It's not a bidirectional exchange. So if I do make changes in Twinmotion, I can't push them back to Revit, but that kind of defeats the purpose of Twinmotion anyway. We're not using this program as a design authoring tool. We're using it really strictly as a ArcViz program or ArcViz tool, much like Lumion or Enscape. So having said that, a big thing that our customers are coming to us and asking about probably in the past 3-4 years is how they can use virtual reality or how they can get to augmented reality. Twinmotion is a great one-click solution to get to virtual reality, and it's built on top of the Unreal Engine, which is a gaming engine. So I'll kind of discuss that when I get into the mesh part. But in the Unreal Engine, we can get a pretty quick to augmented reality solution using that gaming engine. So anyway, the process for bringing this in, I'll just kind of speed this up to show you, but inside of Twinmotion, it's a pretty simple process. You just import the FBX file. So I grabbed the Richmond office FBX file, really small, 1 meg. The nice thing about an FBX is any of the materials that you assign to it inside of Revit will come through in your import if you choose so. So there's an option when you go import it that you can bring in the materials. I personally like to keep the hierarchy of all my geometry with the material assignment to split things up. But this is the process of bringing it in, Z-axis up, blah, blah, blah. For the sake of what we're seeing here, the background is just a default cityscape background, and the ground is this herringbone brick pavers. You can change all of this stuff, but I'm not going to get into all of the settings in Twinmotion and how to change our scene or anything for this presentation. What I really want to show you is what we get from the scan, or from what Jeff created from the scan. So Revit can do its own stuff. We can visualize the space in Revit. It can render out. It's pretty good. Even in 2021, they made it so that you can do some nice real-time rendering. It just doesn't have the capabilities that some of these other programs like Twinmotion and Lumion have. So when I set this one up, I did delete this door out. I probably should have just made it a swinging door like the rest of them. But to get the idea across here, Jeff built this model up in Revit, and I am able to really easily navigate around this model inside of Twinmotion. And as you can see, the desks and things that he placed, they do have the Revit materials assigned to them, so they're not that nice. Twinmotion allows us to replace materials very quickly, very easily, and it also allows us to replace assets like these chairs. So something that we get a lot out of in Revit, with Revit families, they're great because they can hold all types of information, and we do get some nice visual data from them. But if I was showing this to a CEO or something, they're going to say, hey, that chair looks like a block of Legos or something. It doesn't look like a nice chair. So I can quickly swap this out with something that's more visually appealing. Revit has its own purpose for documenting and creating BIM models, or creating the digital representation of the model and deriving information. It can do visualization. It's just not the best platform for visualization. So we can start to swap different things out. If I did want to keep this as a wood desk, I can grab a Twinmotion material like cedar. You can see it starts to get better. We can start to bump reflection, change color really quickly, and do some pretty nice, cool stuff in here. But to keep on track with the purpose of this presentation, I don't want to get too hung up in the actual workflows in changing materials and things in Twinmotion. Rather kind of keep this focused on the data that we're gathering and then building these scenes. So we kind of already have gotten to that point with creating the Revit model, bringing it into Twinmotion as a visualization. Now maybe I want to spruce this up with some more realistic items. Well, Twinmotion does have a number of out-of-the-box objects. For example, if I wanted to bring in a different chair or something, nicer office chair, I could drag and drop in an office chair that looks a lot better than this one. And it does have some quick tools to do that. So I know I said I wasn't going to get into this too much, but my inner geek just can't stand seeing all of those clunky looking chairs. So I'm just going to replace these out real quick with a Twinmotion chair. So I can find and replace basically all of the objects from the Revit model, pick them, start the replacement. I see that they're all rotated the wrong way, so let's change the rotation here. I might have to go through each room and figure that the correct rotation, but let's try 90 degrees. All right, negative 90. It is. Perfect. All right, delete that. So you see, simple process. I was able to make those chairs a lot nicer. I could do the same with all of these desks, but I'll save you from seeing that as well. But one thing that separates Twinmotion from these other ArcViz programs is that we do have the ability to create and store our own libraries of content. So out of the box, we get some pretty good stuff. But what if you're using Herman Miller in a project, or you're using a Steelcase chair in a project? Well, we can import those objects as FBX data into Twinmotion, and we can start to build our own libraries. Now, how does this relate to photogrammetry and meshes and all of that stuff? Well, instead of worrying about using Revit families or something that maybe is a clunkier piece of geometry, a number of companies are starting to use photogrammetry to process and produce 3D models of their content, like chairs and desks and all different types of stuff. And instead of having to sit there and physically remodel it for visualization, we can make these pretty light models from photogrammetry. So let me deviate outside of Twinmotion for a second. I've set up a little scene in 3ds Max where I want to show you this idea. So in 3ds Max, I've imported an asset that I grabbed from a site called Quixel Megascans. So I want to just show you real quick. Quixel Megascans is a partner with Epic Games, who produces Twinmotion and the Unreal Engine. When you sign up for a license, or when you sign up for Twinmotion, I don't even think it actually requires a purchase license, but you get access through your Epic Games user ID to this repository of all of these different, they're called Megascans. So Quixel has a team of individuals that go out all over the world with some pretty high-end photo equipment and some scanners, and they start to scan the environment and create these different objects. So this is kind of what I'm getting at with the manufacturers doing this. Quixel Megascans has a huge, vast library of really very realistic objects that were taken from photogrammetry, and so these are actually all real objects that were scanned somewhere in the world. What's cool about this is that through this program or through this interface, Quixel Megascans, we can grab 3D objects like a sculpture. So this is the one I'm using in this example, but we could grab a sculpture like this. Thought I was logged in. Let me just sign in real quick with my username. And we can download these objects. When you go to download these, I'm going to spare the time of downloading this 3D object, but you have the option of picking a level of detail, an LOD that's assigned to the surface or to this mesh. Now, it's kind of backwards to probably what we're used to in architecture. Let me just open this up. So in the example I'm about to show you, I downloaded the statue, the bust of that woman's face earlier, and it has all of these different levels of detail that we can use. What's different is that an LOD 0 is the most detailed, and then it goes all the way down to an LOD 8, so level of detail 8. That's just something that's kind of standard in the gaming world. Instead of your LOD 8 being your highest level of detail, it starts at the highest and then goes down. Unlike with BIM execution plan, when we talk about level of development or construction documents, level of detail, we have levels 1 to 5. We don't need to get into that, but your most detailed one is always going to be the 0 and then go through that list. The reason I'm talking about this is because we always have to determine what the use of the model is going to be. So in this case, I brought in this asset and all of the different levels of detail. And you can see that at the highest level of detail, we're getting, and actually this is kind of interesting, and I didn't realize this until today, the LOD 0 is going to give us an actual quad or a poly mesh surface instead of a triangulated mesh. And what that basically means, and it's hard to see here, maybe if I actually click on this and grab this, but the difference between a quad and a typical triangulated mesh is that it's broken down into quad surfaces. So instead of a triangle, this is a four-sided shape that's tessellated across the surface to create this bust. If we look to the right of it, this is a normal mesh surface that has triangles. And if I click on, let's see if I can get this here. There we go. Click on this one and select it. It's broken down into triangles. So the reason I like to point that out is that a lot of times the quad surface is larger. It can sometimes contain more detail, but ultimately it really doesn't matter. We're creating a mesh from a scan, and it's gathering these points to create a surface. And as you can see, sort of almost like a geometry gradient, to the left we have a very high level of detail, and then as we go to the right, it really starts to break that poly or break that mesh down into less surfaces. So you might be wondering, well, why wouldn't I always use the high density one? That can have an extreme impact on the performance of your models. So if we get into a program like Twinmotion, or even if we're doing renderings in 3ds Max, I usually tell customers or students in classes, we really only need to use a high density object if it's very close to the frame or very focused in on your visualization, where you're going to see a lot of detail. The same tricks are pulled in video games. I'm sure if you are a gamer, you've seen this in a video game. When you're right up on something, it looks nice and detailed, but then as you sort of move further away, you might see it start to process and it become more like the one over here on the right. So these gaming engines can actually bake in this level of detail, and I don't have enough time to get into all of the properties of that, but The Unreal Engine can use different levels of detail based on distance you are away from an object. For our sake, for ArcViz, if we're just doing still images, then we can probably get away with a higher density surface. If we were doing an AR or VR walkthrough, and well, especially with AR, because the hardware isn't as powerful, we need to start to consider objects that are lower poly. So it's really nice with the Megascans library that we have the option of grabbing different levels of this. And what I wanted to also point out with the mesh is that we can take these objects. So if you do create your own meshes from photogrammetry, you can bring them into a program like 3ds Max. One thing Jeff didn't show about the whole process of the point cloud is when we scan stuff or when we create a surface from photogrammetry, a lot of times we have to clip part of it out to kind of clean it up and make it a nice object like this. So maybe when they did the photogrammetry of this statue, they probably picked up a table or whatever it was sitting on, and then someone came in here and clipped that surface out and cleaned it up. Same goes with the point cloud. You're going to get points that are outside of really what you want to capture, and a lot of times you have to crop that out and clean it up. So that's part of the process, but using a program like 3ds Max, you can actually edit the surfaces and clean them up. Before I get into anything here, I just want to show you that with an editable mesh, I can pick on different vertices. Say you don't want the base of the statue, we can highlight the base, we can delete it out, and we can start to manipulate and change that mesh. I can connect the bottom and do some different things. So, mesh editing is becoming a very big thing with ArcViz because of the need to get into VR and AR. So 3ds Max is a great tool to start to clean up and edit these scans. Let me back out of that. Okay, so one last thing in here in 3ds Max. Something to also be aware of, and this just goes really for any type of visualization workflow, you can pull off a lot more detail with using different tricks than having a super high density mesh. Let me turn off my wireframe override and just go to my default shading. So I have the material assigned to this object, and that material, just kind of plug Quixel Megascans again, that material does come with the download. So this is just a albedo or diffuse texture map. So you can see that the surface, when we do photogrammetry, it does unwrap a surface and tie it to the mesh. So this is the type of material that we get from it. In 3ds Max, I just created a bitmap and tied it into a simple physical material as the base weight color map. I turned some of the reflection down so it didn't look really glossy. But what we're seeing now is, that nice stone feature on the surface. What I mentioned before is we can pull some tricks with the material, so we don't necessarily have to have the most detailed object, which is going to save us on performance. So sure, you can see on the left that this one looks nice and smooth and the material shows up well. We might really not see much of a difference until we get to maybe this option or this option. Obviously all the way down the line here, it really starts to deteriorate, but there is a level of detail that you can be satisfied with that's not going to kill the performance of your model when you're setting up scenes for virtual reality and augmented reality. I'd probably be happy with, depending on what type of focus I have for this object, I'd probably be pretty happy with this level of detail. It might have some jagged edges, but really, if it's not the focus of my rendering or of my animation, if it's just sitting in the background, we don't need to get into this really high poly resolution. So just kind of cool, how realistic this looks once we have the material assigned to it. Now, you could save this out of 3ds Max as an FBX with the material assigned to it, and then bring it into Twinmotion. So to kind of wrap up my part in really the whole presentation here, tying all of this together, I'm now going to bring an object like this into Twinmotion and save it as an asset that I can use in all of my Twinmotion visualizations. It's a pretty simple process, just like bringing in the Revit model. I'm going to import the FBX. So let me just navigate to this. And which value? I said LOD2 was pretty good. It's a super, super small file. I mean, 83 kilobytes, that's barely anything. I mean, I could really get away with the 258 kilobyte. It's not going to hurt. But yeah, I'll bring in the biggest. Go big or go home. So when I import this in, I'm going to keep the hierarchy of the material. Click OK. Sure, default material. And it's putting it at my 0. So, whoops, where am I at? Imported it in. Let me go to, there it is. But this object does not yet have the material assigned to it. So what we're seeing is just the generic, leave that door out, the generic material that's assigned to this. So in Twinmotion, the process of assigning the material is super, super easy. There's my default material. I'm actually going to go, you know what? I want a new material. Tie in my texture map. So to navigate back to Twinmotion. Pick my albedo. It usually takes a second to update it, but did that update yet? Let me isolate this thing. There we go. Panning around sometimes. Oh, I know why it's not showing. I created a new material, but I should probably assign it to the object before I try to see it on the object. So just drag and drop. There we go. Looks good. We can change the luminosity of that, darken it, actually make it grungier, which might be hard to see on the presentation here, but as we kick this up, it just makes it look a little bit dirtier. And then you can also make it a more reflective surface, so it's kind of looking pretty cool, like a marble statue. But the last thing I want to show, so take the time, bring the scan in, everything looks good. Maybe I want to use this if we're setting up a scene that has a lot of this, or maybe this asset's not the best example, but to create a custom user library inside of Twinmotion, we can take a scan. I'll just do a new folder here. This is my new category. And if I want to add this now to my custom category or custom library, all we have to do is right click it. I'd probably rename it first, statue. And add it to the user library. What's great about it is that it stores this object to our user library plus the materials that are assigned to it. There it is. So if I were to close this file down completely and create a new scene from scratch, say no to saving it. So whole new project, bringing in a different model, whatever. Think if you built your whole library with assets in here, to bring them in, you just drag and drop. I don't know why this does this, but by default, sometimes it flips them on their side and you just have to rotate them the first time you bring them in. But I don't know, it's set to 180, and then I get to flip this way. Get that to kind of snap to 90. But take the time as a visualization artist. You can do all of this stuff. You can build your libraries, and then the great thing is you can reuse them over and over again. Twinmotion's at a price point that anyone can afford. Right now, we have a promo cost of like $330 on it. So you can reach out to Aurora or someone if you're interested in purchasing some Twinmotion. It does have a free demo or free trial that is non-expiring, so you can use it for as long as you want. The limitation to Twinmotion is that you can't export anything over a 2K with the trial version. With the full version, you can export resolution as high as you want. And so that, I think, is, we're right around 150. I think I'll wrap it up there, and we can open up for questions.
Yeah, Vince, let me ask you something. This is Jeff. So I often get the question of, hey, man, you guys can create these meshes from all this point cloud data. I'll just take that into Revit. Explain what the advantage or disadvantage of bringing meshes into Revit could be.
Yeah, so you can definitely import a mesh object, and it depends if it's an OBJ, or it depends on the file format, but you can definitely import a mesh into a Revit family. And we've seen this a lot, especially with manufacturers. They do this if they already had legacy data that they built in 3ds Max, and they just want to be able to create a family for architects to plug into their buildings. They'll just import the mesh into a family and then make it a chair or something, and then you bring that into your Revit model as a chair. The problem with that is it has a huge negative impact on your Revit model. Even with advanced hardware, if you have a nice workstation, Revit does not process surfaces like these other programs like 3ds Max or like a 3DR does. Just navigating it around it, or even like in Twinmotion, this is not bogging my system down. If we brought a mesh into Revit, it's going to blow up your file size, and it's going to make navigating your file extremely difficult. So we always advise against bringing in, especially with furniture, because what do we do with furniture? Well, we bring in an asset and then we copy it around in our Revit model 100 times. Well, Revit is just going to have a really, really tough time and chew up a ton of memory when you bring in a mesh. So I guess the advantage is, yeah, if you want it for visualization, you can do that in Revit. It'll come in, it'll render out okay. It still doesn't render out with the shading like it does in these visualization programs, but there are things to be aware of with bringing a mesh into Revit. Did that answer you, Jeff?
Absolutely. Yeah, we get that question all the time, and just because you can doesn't necessarily mean that we should.
Right.
So, I've had a couple clients go, oh, I'm just going to create a mesh of it. I'm like, yeah, I really wouldn't do that. Well, they try it, and they bring in a small office building that they've created a mesh from. And all of a sudden they're like, my Revit file won't open. Well, remove that mesh and see what happens. And then all of a sudden, all is back to norm. So, we didn't cover every single piece of software. There's so many different cool tools out there that we can use. Just to mention one, it's called Point Views, powered by Jetstream. Allows me to create a mesh. From the mesh, creates me a level 200 BIM model automatically-ish. I can take that, bring it right into Revit, and start taking it from there. So there's a lot of different things that we can do, but hopefully some of the things that we've touched on today kind of kicked off some light bulbs, and I'll turn it over to Gladys right now. We use the Leica RTC3